So today we are discussing about ANOVA, and before that, yesterday we discussing about post-summary test, right? So I'm just going to introduce the repeated measures ANOVA also because yesterday we don't have time to be explain the limited measures ANOVA. I'm just explaining this when we can use the repeated measures ANOVA. Repeated measures ANOVA, it is like an extension of a post-summary test only. So when we can use the post-summary test, any idea? Do you have any idea about post-summary test? Yesterday we discussed when we can use the post-summary test. When we can use the post-summary test? Any doubts? When we can use the post-summary test? Anyone please come forward to give the answer. Don't worry about right or wrong. I maybe give this answer for this later. Please. So what, when we can, of course, it's an experimental study. I'm talking about post-summary test in what context? Even experimental method, we are using both independent and dependent sample test like a per sample. Which context we can use it here per sample test? Of course, the answer set is correct, but the context, you can tell this hypothesis. Which hypothesis may be? Yeah, when we have the two tests, pre-test and post-test and one group, correct? So, Catherine and Nithya, you are correct. As already Hani Babu, you are correct. So, if there is a one group, it may be a control group or experimental group, but one group with a two tests. That is for per sample. But there is a test called repeated measures ANOVA. Listen, there is a test called repeated measures ANOVA. If there is only, if there is only one group, but you have the measurement, you that conduct the test three times, like for example, pre-test, post-test, or post-delete test, three times, or you are conducting the four-time examination, five-time examinations. So you are conducting the same variable for five times, five different phases. You want to know which phases the students having more mark or more changes happened in this course. For this, we are using the repeated measures. And I hope you are getting this. Per sample test is mainly for the two tests only. Suppose more than two tests you are conducting, we need to go with some alternative statistics because per sample test, as already mentioned, this there is a limitation. One group with the two tests. But suppose if you have more than a two tests, what kind of statistic? That is called repeated measures ANOVA. So that can we do it now? Are you ready now? So for this, I request all to yesterday, I'm sharing the link that is in that's based on the experimental method data. I request all to open the experimental data. Suppose if you're not find it now, so I request all to go to the folder which I shared yesterday. I mean, regularly I'm sharing this. When you go to this Google Drive, go to the Google Drive link and download the third. So if you go that Google Drive link, you can find out this one. Like the folder name is called a JAMO, I mean dataset demonstration. Click it and download the third one. Download the third one. Just downloading. Okay. So what you can do, you can click this demonstration. You can download this one. So this is things you have to download. So you can see this, yeah, fourth one, experimental Jamavi date, I mean, set OMB. So kindly download it. Do you know when they click the three dot, you can find the download, kindly download it. So those are downloaded, you can type D in the chat box. Please, those are downloaded, you can type D in the chat box. Hope you downloaded yesterday. Apparently, I want to ensure whether you downloaded. Please kindly type in the chat box. If downloaded, type D. Then after that, kindly open a data set of the experimental method. Kindly open a data sets. Thank you, Harshita and Ruksha. Yeah, please, I request all to click this data set of Geomobi because I already shared an OME file. OME file is nothing but the Geomobi extension file. There we have already data sets there. Okay, already data set is there. Yeah, now so hope you open this. Hope you open that. Okay. Now I request all to look onto this. Now the new case is coming. So now this is an interface. How many of them having I mean, if you downloaded new things, you cannot find the filters. If you find, how many of them are having the filters in your end? So because I removed this the yesterday and uploaded a new one. That's the reason there is no filter. Suppose if you downloaded the things yesterday, you can find the filter. Suppose you find the filter, how you can delete it? Go to the data, click that filter. You can find the filter option, kindly delete it. Kindly delete it. If there is a filter, means kindly delete it. Yes. Now I'm just going to explain. And before that, just you can see this data set. Okay. So what are the tests is the pre-knowledge, pre-understanding, pre-application, and pre-total. Therefore, pre-total is there. So main variable is the pre-total, pre-test total, because they're finding some kind of achievement. There is a pre-level one achievement. And the post level, they have one achievement test. That's called post total. Then after a few days later, that is called follow up. That is called deleted posters. I keep the D posters. Therefore, how many measurement is that? So how many times I done a measurement? Any idea? So according to this data sets, that how many times I conduct a measurement, different level of intervention, I conduct a test. How many levels I conduct the test? Kindly respond the chat box according to the data set. So there is a pre-test, there is a post-test and post-delete test. Therefore, how many tests? How many level? How many level we have? How many level we have?
Three.
Yes, of course. It's a 3 level. It's, of course, you are correct. It's a 3 level. Yeah. Now, what we are going to do? We are going to do the repeated measures ANOVA. So now, in this case, what you can do? Uh, always for analysis, go to the analysis. Go to the ANOVA. Go to the ANOVA. Go to the ANOVA. When you click this ANOVA, you can find out the options called repeated measures ANOVA. Repeated measures ANOVA. So when you click this, you can find the repeated measures ANOVA, and click this repeated measures ANOVA. When you click this repeated measures ANOVA, you can find this. So how many are able to find this? You are able to get this, the repeated measures ANOVA? Are you able to find this repeated measures ANOVA? If possible, I request all to turn on the camera, if possible. If possible, I request all to turn on the camera. It will be good for interaction with each of us. If you are sitting in a proper place, kindly turn on the camera. Okay. Now, listen. You are getting the data sets. Okay. Now, are you able to see this RM factor? RM factor is nothing but we have the three kinds of, we have the first interaction, second interaction. There's a 3 level of interaction is there. So I'm just putting this instead of RM factor and put the interactions. There's a 3 level of interaction. I'm going to check the 3 level of interaction, what way that scores might be changes, right? Or 2 level of interaction, like a I mean, 3 level, you can keep it as a 3 level. We are going to check before the interactions and after the interaction, after a few days, what may be changes. Okay. So kindly give us an interaction. You are finding this level 1, level 2, and level 3. Suppose I'm going to give this level is a pre-level, and second level is post-level, and third level post-delayed. Post-delayed. Okay. Post-delayed. Or you can, what is the follow-up? You can use the word follow-up. That will be better. Follow-up. The level is called follow-up. Okay. The level is called follow-up. Okay. So now we have the 3 level. Any doubts? Are you able to create a 3 level now? Did you create the 3 levels? Did you get the 3 levels? So here, what is the hypothesis? Anyone tell the hypothesis? The hypothesis is very simple. There is no significant difference. EMI, pre-test, post-test, and post-delay test or follow-up test on the control group or the experimental group. So you can go to only single group. Okay. Now we done this, right? After this, we need to keep this data. So you can see the repeated measure cells is there. So we need to keep the pre-scores here, keep the pre-total and track it here. Listen, select the pre-total and track it the pre-level. And select the post-total and track it the post-level. And go to the D post level, that's got deleted post, put it in a follow. Now automatically the scores may come. So you can see that the scores are maybe emerged now. So now I input the pre-score and post-score as well as the post-delete score. Now that Jamovi is going to give this, scores, the data is going to be generated now. So kindly check, is it working in your end? Yeah, I got this output. Now the question for you, whether that outcome is correct or not. That results when it comes, no, is it correct or not? So what is our hypothesis? There is no significant difference. EMI. There is a 3 tests, pre-test level, post-test level, as well as the follow-up level. How the changes happen in the control group. So, but the output which comes is correct or not? My questions. Can you give this answer for this? If it correct means why it's correct. If it wrong means why it's wrong. Can you give this answer? Because yesterday we discussed these things. Please come forward, please. Then only the interaction should be good. From your questions, the other people may be benefited. From your responses, the other people may be benefited. Can you tell this answer for this? So there's a response less than 0.001. It is significant or not significant? At least you can give this. Is significant or not significant? The response significant or not significant? Is it significant? Yeah, Mageshwari is significant, correct? Because the p-value is less than 0.05, it is significant. But the answer which is find this right or wrong, it is wrong. Why? It is wrong answer. I'm telling that this is a wrong answer. Can you tell me why it's wrong? I mean, of course it's wrong, but why it's wrong? Yesterday we done one changes during this per sample test, but we done it. We doesn't do this now. So we didn't do this that particular process. Directly we done here this process. So that is a process called filter because we didn't do the filter. You can see this number of sample here. I mean, you can see this number of degrees of freedoms. Uh, 43. It seems a 44 is a sample n minus 1. The issues here, our control groups only 22 people only. Experimental groups 22. But here it comes at 43. The problem with this software, if you import this data, the results maybe comes. But we can ensure that the output it comes correctly. Because this output comes for the 43 samples. But our sample is only 22. Therefore, how we can solve this? How we can solve this? Any idea? How we can solve this issue? I need only 22
The
samples.
filter.
We need to
Filter.
go to filters.
Okay, very good. Go to the data.
Filter.
Go to the data.
Go to
Then
data, select
filter.
filters.
Very good. Then yesterday we
Then
discussed.
have to go
Yes.
to the plus sign. Okay, and
Then
we have
group
to write
type as it is.
equal
How many
to
times equal symbol?
2 times.
2 times and 1.
And one.
Yeah. Then parallel you can add second also because we need to disable this. Yeah. And I'm going to the second. How to add the second group? Group plus symbol. Go to the plus symbol. Go to the plus symbol. Then go once again a group.
Equal to group and then space.
Space, then
double.
1 space and 2. Okay. Now we need to only 1. So kindly close this first experimental group. So now kindly activate the experimental, deactivate this. So it's both is active, but deactivate the experimental. Therefore, which group is only alive now? Only control group. Now we can see this output now. We have the output for the control group. The control group, is it significant or not? Is it significant? Control group, is it significant? Yes, it is significant. Okay. But when you have a significant, we need to go with some kind of advanced calculations. For this, we just looking on down. You can see this. And just going back once again to the analyze part. And going back to the analyze. Okay. So there is this, yeah, I'm going to the ANOVA. And we are doing the repeated measures ANOVA. Please, I'm doing the repeated measures ANOVA. And what we can do here, so you can see this, there is a model. You can go to the post hoc. Why? Because we understood that there is a significant. Therefore, we can go to the post hoc. Under this, you can keep this RM factor and go with this one. Okay, RM factor. And go to the Ducky. Go with the Ducky model. So when you click the Ducky, automatically the reports may comes here. There's a Ducky. So there is a response may comes. So the response will comes now. Only there is a small slow in my. So once again, go to the ANOVA. Kindly check the results come for your case. I'm just going to the, yeah, now the repeated measures ANOVA, RM factors, the between, it's, yeah, now the post hoc is comes, post hoc. So you can see this level 1 to level 2, level 2 to level 3, you can get this, all the differences, maybe get this. How many they got this output? How many the people got these results? Those who are getting the result, you can type R in the chat box. Those who are getting the results, you can type R in the chat box. Hope you understood that when you can use the repeated measures ANOVA. The repeated measures ANOVA, it's an exercise per sample titers. If you have only one group, but you are conducting a 3 levels of measurement or 4 levels of measurement, more than 2 levels of measurement is there. You want to know that which measurement level, whether the pre-level or a post-level or post-delay level or post-delay 2 level, post-delay 3 level. If it's significant arise, that for this we are using this mode. Okay. So hope you are getting this how to do this. Repeated measures ANOVA. I'm just telling this path, go to the repeated measures ANOVA. And what you can do here, so you have to give this and just to give this response. Just see this. Once again, I'm doing this. So here you can give this interactions. The level 1, give this pre level. Then second level is a post level. Third level is a follow-up level. Okay. Then after this, what you can do, so there is a spelling error, kindly. Okay, follow up. Okay, follow up. Okay, right. Then you can keep this pre-total and repeated measure cells. Keep it here and select the post-total and put it here. And the last one, post delete, that also keep it here. Okay. So when you keep it here, that scores might be emerged now. So the scores will comes. You got these results? Did you got the results? For me, it's a small, slow. Those are getting the results, you can type or in the chat box. Okay. So here we can go with this model. So these are the things, not necessary all the things. So which are things needed, you can do this. So if you want a partial eta square, click this partial eta square. If you want to check this post hoc, you can click the post hoc. This way we can do this. Hope it is working well for your case. For me, that small hanging is there. Okay. Because morning under the system's open, no? Yeah, you can see from here, you can understand. Now you can see this, there's an interaction effect, is significant, and 21 degrees of freedom. So this way its results comes. Suppose I want to go back to the experimental group, what we can do? Now the control groups comes. I want to I want to generate a result for the experimental group. What we can do? Go to the data and go to the filters, go to the filters, go to the filters. This is you can deactivate. Then this you can activate, extend the group you can active. Automatically the results may be changed here. Okay, automatically the result might be changed based on the changes. Based on the changes, that scores might be changed here. Okay, so the scores will comes now. So this way we have to do a repeated measures ANOVA. So can you move to the next level? I hope no doubt, right? So I'm just asking the questions. What is the extension of per sample test? Suppose you have only 2 tests, you can go the per sample. If more than 2 tests, what's the statistics we can go with this? What's the statistics? What is the statistics we can go? The statistics name is called repeated measures ANOVA. Why is called repeated measures ANOVA? Because the measurements conduct repeated times, more times. So now you can see these results. You can see the results coming now. So it's showing this first results. It's going to come the second results. Still is coming. Okay. For your case, the results comes, right? Your side.
Sir, how to do a post hoc test?
Madam, scroll, yeah. Post hoc test. Suppose if it's significant. If it's significant, go to the post hoc side. Post hoc side. Anyone's ready to share your screen? Because I have some slow happen. See this data set. I'm just close and open this. There is a small. And just close this. Okay. Yeah. Just close this. I think I have a lot of documents might be open. I just close this. Okay. Okay. And just come back to open here data sets which I downloaded. So once I now open this. Sorry. So this is in, no, I'm just going back to this one. Yeah, I'm just opening the same data sets which I given to you. Yeah, so this is a data set only doing this experimental geometry data set .ome file. So once again, kindly look onto my screen now. So please.
Actually,
Yeah.
yesterday we were not able to download this file, sir.
Why?
.omb file. We are getting the older one, which is in the form of PDF, and it's opening in WPS Office.
Madam, I think there may be whether you install the software. Did you install the software?
Jamovi. Yeah, sir.
But then it will be over. What about any other people having these issues? It's not opening like this. Hope it may be because I'm sharing is a OME file only. So it may be working
when we are
well.
doing the thing, practicing it, what's happening? We are getting all the dashes here. We are not getting any numbers here.
Okay, okay. So now you are getting this. Now you are getting the data.
Not even today, sir.
What about others?
I think if you are facing the same problem, because yesterday if you had mentioned the same thing in the
one thing. Suppose you have you have a Excel data set, no? Better to download it. Suppose if that issues comes, I request all to go with this, close this. Go to the Excel data sets. There is an Excel, no? Fourth. Suppose if you have that issues, I request all to download the fourth one. So just showing this. The data set which I shared no yesterday, and there you can find out this one. There is an Excel sheet number 4. Excel sheet number 4. You kindly download this. Excel number 4. So this one, I'm talking about this one. Yeah. So do you have this data set experimental? Do you have, ma'am? Kindly download this. Then after that, you open a Jamovi file. So you open a Jamovi. You can open a empty Jamovi. Sometimes if you're not open, you can use this method. So open a Jamovi like this. You can import that Excel file directly into the Jamovi. Hope you're open this. Yeah. Now open a empty Jamovi file. So how we can be import the data into here? Any idea? We discuss. Go to the, what is the tool? What is this tool
We
name?
need to go to the hamburger.
Hamburger. Correct. It's a hamburger. Go to the open. Then
Go to open
go to
and
the
then
browse. Go to the browse.
And select the file location.
And select this, the file. Yeah. For example, my file, I'm just going to locate this from desktop. I'm just selecting this. See, 1 minute. So my presentations. So I have a lot of path is there. So hope you are getting this file very fastly. I'm just going with this because I have kept it a proper folding. Okay. And just continue with this particular, data demonstration. Yeah. Under this, the third one. So fourth one, select and click open. So it's open now. Is it open? Now it's okay. It is open now. Anyone's having the issues now? Okay, so Harita is working well. Okay, fine. Hope you are getting this. The issue with this, the group is a categorical variable, but the pre-knowledge and it's not in the categorical, it will be continuous. So what you can do, just fastly, you can modify this. Double click here. Go with this one. The first variable is pre-knowledge. Make it as a continuous. Make it as a continuous. Yeah, then second variable as pre-understanding is a continuous. So make it as a continuous. Suppose you are keeping as an categorical. So sometimes we cannot run this software. Sometimes there may be issue while running it. So I request all to modify first. When you doing the data analysis, kindly check this that data how it will be there, whether it's a nominal, ordinal, or interval or ratio. So you have to define properly. So I'm going to the continuous and continuous. And click the next post also continuous. And the next also continuous. Sorry, post understanding. So all the variable except group is a continuous. I request all to modify post applications. Then post total is a continuous. Then the next one, the post is in continuous. Okay.
How do we identify the categorical and continuous data, sir? Are there any?
We already discussed, no, ma'am. So if it, for example, this goes from this like a continuously comes. For the categorical variable is a group nominal. Sorry, this only the control group experiment. It's a categorical. But if you are continuing the post test score, it's like achievement score. The score may be 50 mark or it may be 30 marks. So the scores may be 1 to 30 or 1 to 50. Therefore, automatically is an equal intervals. You got it?
Okay.
There's a score. The achievement scores may be 1 to 50 or 1 to 100. Therefore, automatically says the scores are continuous. It will be decimal also possible. That's the reason we are keeping this kind of achievement score as a continuous. Okay. This is basic understanding about the data sets. Okay. Now, after this, what you can do, go to the filter first. So how to go to the filter? Go to the data. Go to the data and go to the filter. Go to the filter. And that filter is based on this one. What is this group? So type as group as it is. Type group as it is. The spelling should be very cautious. Equal and 1. And the second filter, group. Second filter, group. 2 times equal, number 2. Then is okay. Then now kindly deactivate at least 1. So I'm just doing the calculation for the control group now. Then after this, what you can go to the analyze. Then I just close this. Go to the analyze. Go to the ANOVA. In this ANOVA, that is called repeated measures ANOVA. Click this repeated measures ANOVA. Under the repeated measures ANOVA, you are getting this kind of interface. Yeah. So here you have the three levels. If you want, you can give this level. Okay. So there is a three levels of test and going this interactions here. The interactions of the three level. This is a pre-level. This is a pre-level. Even you can keep it level 1 level. This is not an issue. Pre-level, post-level, and follow-up level. Okay. Follow-up level. So like this, you can define this. Then after this, keep this cursor and keep this pre-total. Select the pre-total and put it here. Automatically the pre is there. It automatically comes here. Okay. Next is here, not post. Okay. If you select it wrongly, so kindly shift it like this. Select and shift it. Okay. So kindly put it proper variable. Okay. So I'm just moving to this post knowledge in this case. The problem. Yeah. So I'm just keeping this post total. Okay. Oh, sorry. Yeah, so I'm just changing this. So you have to select this. The problem, I have some problem with software, I think. One minute, I'm just trying this. For your case, the results comes. For your case, the results comes. Kindly check the results comes means okay. Because for me, there is a small, because I use my laptop from morning onwards, no? That's the reason some kind of delays happen. Delay is there. Hope it is working well for your case. Right? I'm just going back. Okay. So once again, the same ANOVA, repeated measures ANOVA. So I'm just going with this level 3 only. So I'm using the same level 1, level 2, level 3. I'm using the level 3. So instead of a pre-test process, because there is a, yeah, level 3. Level 3. Yes. And I'm just keeping this pre-total. Keeping the pre-total. Just making the pre, post, delete. Okay. Then go with the enter. I mean, space, then automatically it comes like this. And pre-total. So automatically go to the repeated measure cell and select this particular variable and select a post total. Then select the post level. Then post delete, select and go to the post delete. Okay. If you have the 4 level, you can go to the 4th level. Okay. Now the score maybe comes down. Suppose you want to do a post rock. There is a significant comes, go to the post rock. In this post rock, kindly see this, how to do the post rock here. So you have to click this RM factor here, put it here. So sometimes it may be called interaction for your case. Then select the key. Automatically the scores may comes there. Automatically the scores will come there. Hope it is working well. For your case coming, the output is coming. Right? So now the result is coming for me. You can see this harm factor residual. The results comes now, and you will get the post hoc analysis also. Okay. So it's emerging the subject. The first table is talking about the significant, whether it's significant within the 3 levels of measurement. And the second one talking about residual error, but don't look onto this one. Check with this first one only. Then post hoc test, if it's significant, you can check this. How the difference between pre and post, the difference between pre and post as well the post and post delete. Like this, you are getting this output. Is it come to you? So kindly respond. Hope you are getting this output, right? So hope you are understood how to do this repeated meshes ANOVA. As already mentioned, the repeated meshes ANOVA, it is then the extension of a per sample test. The per sample test, according to we discussion, that condition that we have 1 group and 2 tests. If you have more than 2 levels of tests, then you can go with this post repeated meshes ANOVA. I hope there is no doubt, right? Can I move to the ANOVA now? Can I move to the ANOVA? Still, it's producing for my case. Yes. Now I move to the repeated measures ANOVA. Yeah. So the results comes, sorry. Now the results comes now. So how much delay for me? You can say this. Now this is significant. Therefore, there is a significant difference. What is that? The outcome and finding that there is a significant difference among pre-test, post-test, and post-retest on the control group, right? Suppose if you want to go the experimental, you know the filter and go to the select the only two and disable the number one. So now this is a differences pre and post. The pre and post also significant, the key test, and the pre and post also significant, and post and post delay also significant. Therefore, all the three comparisons are the significant difference, like pre to post delay, as well as post to post delay. So all the three groups having a significant difference. Hope you are getting this. So can I close this data set? Yes, now I'm just, if you want, you can save this data sets for further derivation. Better to save this, better to save. In the desktop, you can save. Okay, and saving as a desktop now. If you already say no problem, but I'm just keeping it the desktop for further use. Okay, save this. Okay, now I save now. And just moving to the next is called ANOVA. Here I'm talking about ANOVA. It's not only a one-way ANOVA. I'm talking two-way ANOVA, three-way ANOVA, multi-factor ANOVA. I'm going to discuss now. So please, for this, I'm just using one of my chart. This is I made the chart for easy to understand from your end. So I hope you are seeing this chart, ANOVA table. So this is an ANOVA. I'm talking about one-way ANOVA along with multi-factor ANOVA. So do you know what is called ANOVA? ANOVA. What is the expansion of ANOVA? What is an expansion of ANOVA? Analysis of?
Analysis of variance.
Very good. Analysis of variance. So here, for this analysis of variance, we are using the F-test. But there is a test called Wilks F-test also possible. I'm going to discuss when we can use the Wilks F-test and all. Yesterday, we discussed the homogeneity. The similar way, we can go with this Fisher F-test or the Wilks F-test. So in the two conditions we are discussing. And before that, I'm just giving the theoretical sides about this factorial ANOVA. Listen, there is a factorial ANOVA. I'm using the factorial ANCOVA also. What is called ANCOVA? What is the expression of ANCOVA? Analysis of?
Covariance.
Covariance. Right. Listen, the conditions, kindly check this. And just to use the word statistics, one-way ANOVA, two-way ANOVA, three-way ANOVA, four-way ANOVA. Here I'm using one-way ANCOVA, two-way ANCOVA, three-way ANCOVA, four-way ANCOVA. Now we can say this, the basic condition that independent variable is needed, dependent variable. For ANOVA, ANCOVA, we need both independent variable and dependent variable. But you can see this, I use some terms here. You can see this, you can get this some idea. You can see this. Yeah. Now we can see this, I use the IVS, but I'm using DV. Do you know what is the difference between the two? What is the difference between these two? Why I'm using yes here? What
IV is independent and DV is dependent variable.
Yeah, correct. Why I'm using yes?
More than one could be there.
Yeah, it may be more than one. But DV, only one. Listen, the basic assumption that for doing a factorial ANOVA, your dependent variable should be only one. Please, this is very aware of it. The dependent variable should be only one, right? And that will be only one. What format? What is the format? It should be a continuous. You can see this, all is a continuous. I'm using the example achievement test, right? I'm using that as achievement test. What is the EV? What is the EV? What is the EV? Independent variable, dependent variable. No, what is called EV?
Extraneous.
Yeah, that's called extraneous variable. Extraneous variable. It's like a third Z as a variable. So this variable is not need for the ANOVA. Listen, what is called NE? Not applicable, right? Not applicable. Therefore, if there is no extraneous variable, then we can call as a ANOVA. You understood? The basic that if there is no extraneous variable for your data analysis, then you can go with ANOVA. Suppose there is an extraneous variable. What it called? What may be called? It is called ANCOVA. Hope you are getting the differences. So ANOVA, we don't have any extraneous variable, but ANCOVA, we have a code. Normally, you can think about this is called covariance. Basically, this EV is called covariance. This EV is called covariance.
In case of ANCOVA.
It is a covariance, okay. So, but the covariance only possible for where? Only for ANCOVA. You can say this. I use the term At least one. What does it mean by at least one?
It can be more than one also.
More than one also possible. But what format? What is the format?
Continuous.
Continuous. Please, these are the basic assumptions, must be know this. So this I'm talking about the assumption also. The condition to go with ANCOVA, if you have the extraneous variable, that at least one extraneous variable, you can go with the SATCOVA. There is no extraneous variable, you have only independent, dependent, then you can go with only one, only ANOVA only, right? Now, the next thing, I'm talking about independent variables, right? In this case, if it only one independent variable, it is called one way ANOVA. If it two independent variable, then it is called two-way ANOVA. If it three independent variable, then it is called three-way ANOVA. If four, sorry, here the wrong, it's a four. 1 minute. Yes, yeah. So there is a typing error. So how many?
Four.
Four. Okay, it's a four independent variable. Then it is called four-way ANOVA. Basically, the two-way ANOVA, three-way ANOVA, four-way ANOVA, what is the general name? The general name of two-way ANOVA, three-way ANOVA, four-way ANOVA. Any idea? It is called multifactorial ANOVA. Listen, this is called multifactorial ANOVA. What the name is called? Multifactorial ANOVA. Because lot of factor is the two-way ANOVA, lot of factors. The three-way ANOVA is different factors. The 4-1 is different factors. Therefore, it's called multifactorial. So I'm just giving this one idea. You can give this answer. So I'm just giving this condition. Suppose you have a two independent variable, only one dependent variable, but there is no extraneous variable. Which statistic is possible? Tell me.
Sir, ANOVA.
What ANOVA? What
Two-way ANOVA.
Two-way ANOVA.
Two-way.
Yes. Yes, fine. Suppose you have a three independent variable, only one dependent variable, but you already having one extraneous variable also. Then what we can go with this?
Three-way
ANCOVA.
Three-way ANCOVA. Hope you are getting this. Hope you are getting the clarity now.
Yeah.
Right. Yes. Now I'm just explaining once again with some example. Then you may get this. Right. Listen, you can see this. In the case of one-way ANOVA, as I already mentioned this, only one independent variable, one dependent variable, it should be continuous. What about independent variable? What is the character? It should be a categorical. But the category should be minimum three classification, three subgroups. Suppose only two subgroups, what we can do?
We can go with two-way.
Sorry. Suppose we have only two subgroups only. Can we go with ANOVA? Can you go
No,
with
sir,
ANOVA?
for that we have t-test only, no?
Correct,
For two groups.
You are correct. That's called independent sample t-test. So
Yes.
therefore, the independent sample t-test extension is called what? The independent sample t-test extension is called one-way ANOVA. You got it now? For per sample t-test, what is the extension? Per sample t-test, what is the next level? What is the next level of per sample t-test? We discuss.
Pardon the question, sir.
So for the one-way, for the independent sample t-test, the extension, like the next level of independent sample t-test is called one-way ANOVA, because independent sample t-test, we need only two subgroups. But in this case, we have three subgroups, like government aided, self-finance. That's the reason we are using the one-way ANOVA. Similarly, per sample t-test, there is an extension, like the next level of, suppose if you have only two tests, if you have more than two tests, what kind of test we can adopt? What kind of statistics is possible? What is the statistics possible? We discussed the previous, that's called repeated measures ANOVA. That is called repeated measures ANOVA. Correct. Supriya were correct. Vijay were correct. So hope you understand. Yes, now the questions here. I'm just explaining. The management having the three factors. What is the factor? What are the factors for management? What are the factors for management? Government,
aided and private.
Then you can see this. What is the hypothesis? We are checking with management with the achievement. So how the management is going to affect the achievement? Is it right? What is the hypothesis? Do you know what is the hypothesis? There is no significant effect of management on achievement. This is an hypothesis, right? So therefore, the management have the three factors. What are the factors? Government, aided, self-finance. Gandasamy sir, don't be right. Okay, thank you. And now we can come to the two-way ANOVA. The two-way ANOVA, 2IV, right? So I'm using the management and gender. Listen, management, how many factors?
Three factors.
Gender?
Two.
Yeah, in this condition, please, Gandasamy sir, please, don't use the annotate. Gandasamy sir. Yeah. So, 1 minute. Kandasamy sir. Okay. So can I remove? Yeah. Kandasamy sir, please kindly help us to don't type anything. Yeah. Yes. So you can see once again, hope you are seeing my screen now. Okay. So here, as we know this, the 2V ANOVA, we have here, so I'll just change the color. Okay. Yeah. We have a management, we have a gender. So the 3-factor of management and 2-factor of gender. So basically it's called 2V ANOVA. If you want to tell exactly what ANOVA, this is called 3x2 factor ANOVA. What is the exact name? 3x2 factor ANOVA. Why is it 3x2 factor ANOVA? Because
there are
management 3 category,
management and gender
genders 2 category. Therefore 3 into 2 factor. Therefore altogether 6 factor might be there. Okay. Therefore it is called 3x2 factor ANOVA. But in this case, when you go with this kind of case, we are going to check the 3 hypotheses. What is hypothesis 1? So the hypothesis number 1, management effect on achievement. The hypothesis number 2, gender effect on achievement. The third hypothesis, which is called interaction. How these two things like management and gender together, how is going to affect on achievement. Therefore, how many hypotheses we are going to check? 3 hypotheses. Hope you are getting this. So when you go with the 2V ANOVA, we are going to check the 3 hypotheses. 2 is a main, that is called as a main effect. 1 is called interaction effect. If you want to just explain once again, you can see this and just to clear this. Yeah, now you can say this. The management having a 3-factor, gender having a 2-factor. Therefore, it's called 3x2 factorial ANOVA. But the cases here, we have a hypothesis. First hypothesis, management on achievement. Second hypothesis, gender on achievement. Third hypothesis, how these two together, like management and gender together, how is going to create an impact on the achievement. Therefore, how many hypotheses we are checking now? 3 hypotheses, right? Yes. Now come to the 3V ANOVA. What is 3V ANOVA? How many independent variable? 3. So I'm using management, gender, locality. Can you tell this exact name of this? Exact factor number. Management is a 3. Gender is a 2. Locality is a 2. Therefore, what is that? Factor ANOVA?
3 factor.
3 cross 2 cross 2. Okay, 3 cross. Yeah, please. This is called 3 cross 2 cross 2. Yes, now we have management, gender, locality, best achievement, right? Now, can you tell how many hypotheses may come? How many hypotheses may come for this case? How many main effect? How many main effect? How many main effect? Management.
So
on
total
achievement.
4.
No, listen. Management with achievement, 1 main effect. Gender on achievement, 2nd. Locality on achievement, 3rd main effect. Listen, how many main effect? Main effect means single effect.
6, sir.
Right, 6. Then the next, there is an interaction. What are the interaction may be there? Management, gender on interactions. And management, locality is another interaction. Then gender locality, another. Therefore, 3 double interactions. Along with it, there is a final interaction, management, gender, locality, all 3 together. Therefore, how many hypotheses?
7.
7 hypotheses. Hope you are getting this. For the 3V ANOVA, we are checking the 7 hypotheses. We are getting 7 findings. So we have the 3 main effect and 3 interaction effect for the 2 factors and 1 interaction effect for all the 3 factors. Right now, hope you don't have any doubts about the multifactorial ANOVA. Therefore, it's called multifactorial ANOVA. Why it's called multifactorial ANOVA? Listen, some people are having the doubt about the factor analysis and factor ANOVA. Factor analysis differ. Factor analysis maybe reduce the dimensions. For example, the 20 items. That 20 items, instead of measuring individually, we can reduce the dimension. Like we are going to compile some of the basic property wise. We are going to combine some of the dimension. we are going to make some kind of component. For this, we are using the factor analysis. But factor analysis differ, factor ANOVA is differ. Factor ANOVA, we are checking about how much factor is going to affect on the dependent variable. Right? Can we go with the factor ANOVA, ANCOVA? So what is the factor ANCOVA? I'm just explaining the same. As already mentioned, this the difference between the ANOVA and ANCOVA. What is the difference between ANOVA and ANCOVA? ANOVA and ANCOVA difference, basic difference.
ANOVA does not
Extraneous.
have extraneous variable.
Extraneous.
Correct.
ANCOVA.
Correct. If the extraneous variable only, we can think about ANCOVA. If there is no extraneous variable, don't think about this. Right now, this is as already mentioned. This the independent variable is based on the number. It will be one-way ANOVA, two-way ANOVA, two-way ANCOVA, and three-way ANCOVA, and four-way ANCOVA. Okay. So here also there is a mistakes. I'm just showing this. Here also small mistakes. This is a 4. Listen, this is a number 4. Okay, kindly change this of number 4. Okay, this is a 4. So in this case, because I'm using an annotate, I cannot be. This is a 4. I'm just writing this is a 4. Okay, this is a 4 now. Okay, and in this case, one-way ANCOVA, one independent variable like management, and one-way one continuous variable is dependent variable, one continuous variable is an extraneous variable, right? So what is the hypothesis? Do you know what is the hypothesis? How we can frame this hypothesis? Any idea? How we can frame this hypothesis for this case? How we can frame the hypothesis? How we can frame this hypothesis? What is the hypothesis? Very simple.
So there
We are
is no
using
significant difference of intelligence over achievement and manage government schools and
government schools, self-finance school as well as private after by controlling the covariate of intelligence. Right? Listen, there's like 2 terms I'm just introducing. One is called adjusted mean score. When you're using this factorial, ANCOVA, you can use the word adjusted mean scores. And another one, you can use it, the term, it is called covariate. Okay. These are the 2 terms you can use it for hypothesis framing. Here, the hypothesis is very simple. I'm just explaining. There is no significant difference in the adjusted mean score. For other cases, we are using only the mean score. But here, we are using the adjusted. Why? In the sense, after controlling the intelligence, because basically we have some mean scores. But after controlling the intelligence, your basic mean score might be changed after controlling the intelligence. Therefore, it's called adjusted mean scores. We are adjusting. We are removing this effect of the intelligence, and finally we are checking this what is the exact mean score after controlling this effect of intelligence. Therefore, we can use the term adjusted mean scores. And just explain once again the hypothesis. There is no significant difference in the post, or you can go with this anyone, in the post achievement scores of the post achievement adjusted mean scores of control group and experimental group by considering pretest as a covariate, by considering pretest as covariate in this case. Suppose this was the experimental method. Suppose I'm going to, for this case, I'm making the hypothesis like this. There is no significant difference in the adjusted mean scores of achievement scores with respect to the management by considering intelligence as covariate. Hope you are getting this. By considering intelligence covariate. Therefore, these 2 terms should be available in your hypothesis. Right? Next, the two-way ANOVA. 2 independent variable, it's a categorical variable, and management gender, and 1 continuous variable, at least 1 intelligence. Okay, at least 1 continuous variable is needed. So how many hypotheses may be there? Any tell me? How many hypotheses is going to check? How many hypotheses is going to check? For this case, how many hypotheses? The same like this one. So what is that exact factor ANOVA? This is called 2 cross. Suppose you are finding gender and management. What is that exact name? Instead of management gender, you are going to gender and management factor ANOVA. Then what is called? If you go to management gender, it's called 3 cross 2 factor ANOVA.
2 cross 3.
Yeah. When you go gender with management, it's called 2 cross 3 factor ANOVA. Listen. Based on the order, we can change it. Right now, in this case, first we are going to check with the management on achievement after controlling achievement, after controlling the effect of intelligence. This is an first main effect. Then second, gender effect on achievement after controlling the effect of intelligence. The second main effect. Then third hypothesis, management and gender interaction effect on the adjusted mean scores of achievement after controlling this effect, after controlling this in extraneous variable intelligence. Hope you are getting this. Hope you are getting this.
Yes, sir.
Right. So this is the way we can go with this. Now, can you move to the Manova-Mankova? Can you move to the next one? So hope you are getting this difference between ANOVA and ANCOVA. And now I'm going to the MANOVA, right? Now the MANOVA. So I'm just moving to the MANOVA. Yes, this is a MANOVA, right?
Excuse me, sir.
Yeah.
Sir, do we need to use both the words adjusted mean score and covariate in the
Yeah,
statement that
because
we have?
yeah, we can in that statement we can use these terms. Okay. Because then only the people know that you are using a covariance. You are using that you are using a ANCOVA. That terms is
Okay.
meant for a
Both
ANCOVA,
words.
right? Yes. Okay.
Okay.
But other ANOVA and all you can use terms mean score only. But ANCO only what term you can use adjusted mean score because we are adjusting after controlling the extraneous variable. Therefore, it's called adjusted mean score, right? Right. Now, I'm talking about MANOVA now. Okay, MANOVA. Now the question for you, anyone to come forward. The table, same table only. What is the changes happen? Anyone? So what may be basic changes happen in the case of the previous table and this table? I'm just going to annotate and close this annotate. Yeah. Now you are seeing this the previous ANOVA. What is the difference between this ANOVA and the MANOVA? This another MANOVA table I just showing you. This is called factorial MANOVA and factorial MANCOVA. What is the basic difference you find it
Now,
from these
first,
two tables?
earlier we had only dependent variable, only one. Now we have
Yeah,
more
listen.
dependent variables.
Exactly. Well, you are correct. So in this case, the difference between ANOVA and MANOVA, the difference based between the number of dependent variable. Like, hope you understand this is MANOVA means what is a MANOVA? What is the difference? What is the MANOVA expansion? What is the expansion of MANOVA? What is the expansion of MANOVA? Multi-analysis. You know the ANOVA, analysis of covariance. The similarly multi-analysis of variance only, right? The M represent multi. So the basic difference between ANOVA and MANOVA based on the dependent variable. If more than one dependent variable, two or more, I'm talking about two or more dependent variable, we can go with directly MANOVA, not in a ANOVA. Hope you're getting this. ANOVA is not possible. ANOVA is only possible if only one dependent variable. When the MANOVA is possible? When the MANOVA is possible if more than two or more dependent variable. But all other things are same. Listen, all other things are same only. MANOVA, what is not there? There is no extraneous variable. If it extraneous variable, what it called? If it extraneous variable, what it called? It is called
MANCOVA.
MANCOVA, right? So now the question, what is the difference between ANCOVA and MANCOVA? Difference between MANCOVA and ANCOVA?
So multivariate means dependent variable.
Only dependent. So the dependent variable is two or more, then you can think about, right? Now I'm giving this one condition. I'm just giving this one condition. Based on the condition, you can tell this what statistic we can use it. Are you ready now? I'm having a two independent variable. Listen, kindly read it, kindly hear properly. I have two independent variable. I have two dependent variable, and parallelly I have two extraneous variables. What is the statistics more apt for this?
MANCOVA.
Huh?
Two-way MANCOVA.
Two-way MANCOVA, exactly, two-way MANCOVA. I'm just telling this. Another conditions. You have three independent variable, only one dependent variable, and one extraneous variable.
ANCOVA.
Three-way ANCOVA.
Yeah, it's a three-way ANCOVA. Please kindly note three-way ANCOVA. Right. Now I'm going to another conditions. Okay. You have only one independent variable, categorical format, and you have the two dependent variable and one extraneous variable also. What may be apt?
One-way ANCOVA.
One-way?
One-way MANOVA.
One-way.
MANOVA or MANCOVA?
MANCOVA.
One-way MANCOVA. Right. So hope you are clear. So we are discussing about all the factorial ANOVA, right? Basically, it is called multifactorial ANOVA, multifactorial Markova or MANOVA, right? Any doubts in this? Right? So can you go the Jamovi now? Can you go the Jamovi based tools? Okay. Yes. Before that, I'm just showing this one more. I'm just closing this. Okay. Yeah. Just unedit and stop this unedit. Yes. So now, what I'm going to do, just go to the data set of this one. There is an data set. Are you able to download this? The fourth data set, the third one, survey data the teaching competency. Is it possible to download? So I just explain how to download. Sometimes if you click it, there's a problem if not download it. Instead, you can click the download options. So kindly download instead of a click. When you click this, open it's a PDF file. I request all to download it. So I'll just explain how to download it once again. Go to the data set which you shared yesterday, the drive link. Okay, 1 minute. So just opening your WhatsApp. I request all to go to the drive. Okay, possible. So I'm just trying to drive. So I move to the drive and okay. So the drive, you know that the drive link which I already shared to you. So when you go to the drive, so can you give me 2 minutes time to be restart my system? My system is little hanging now. Can you restart if you're given the time? So meanwhile, you can ask some questions. So what is the difference between multifactorial ANOVA and MANOVA? Sir, as already mentioned this, in the case of ANOVA case, there is only one dependent variable. MANOVA case, it will be 2 or more dependent variable. Can you go with a small shutdown?
Sure, definitely.
Okay, because my system's a little hanging now. So meanwhile, if you have doubts, you can ask me here. Okay, I'm just going, just shut down this. This system, the morning onwards, I turn on this. So that may be issues in this. Rajkumar, I'm just leave this meeting. Kindly, when I request, kindly add me in this group. Okay, this.
To whom now?
And just leave the. Yeah, so hope you are seeing this. If you have any doubts, basically any doubts, you can ask me and just share, restart my system. Okay. You can ask me any doubts regarding that thing. Just share down the system. Yeah. Any doubts up to now, please? Any doubts up to now? Do you have any doubts? You can come forward and ask some doubts. Okay. So, Arun Kumar sir, hope you get this clarity, the difference between the multifactor ANOVA and ANOVA. ANOVA and ANCOVA difference, if you have the covariate, then you can go with this ANCOVA. If there is no covariate, that's called, I'm talking about extraneous variable in the name of covariate. If there is a covariate, then only can think about the COVA, that's ANCOVA or MANCOVA. If there is no covariate, don't worry about this. You can directly go with ANOVA or MANOVA. I will share it. I will share it, Galaxy. I will share that data chart which I made from my end. I will share it. Okay. What data sets to download from the folder? I request all to download the entire data set if possible. You can download the entire thing. And because I said some of the file is an OME file. So kindly check the file which is shared as a OME document. It's opening as a OME, like is opening as in Jamovi file. Kindly check. Because if it's there, I can go with very fastly because I already defined some variables. Otherwise, you can do everything in your end once again. Okay. So I request all to check the OME file is opening. If the OME file is open, you can type O in the chat box. If the OME file is open, kindly type O in the chat box. Kindly type O in the chat box. Yes. Yes, fine. I think Malini. So it's opening, no? Harita is working. It's fine. They're great. Sometime if you click directly, it may be opening PDF file because opening drive, no? Instead of a download and then try for opening. Okay, then the issues may be solved. Okay. The issues may be solved. So I'm just trying to connect with my. Meanwhile, if you have doubts, please come forward. You can ask some doubts and just connect with that my laptop with this. Any doubts? Any specific doubts up to now? Even if you have some doubts related to research, also you can ask me. So I'm just going to the demo at a stretch. All the
Excuse me, sir.
Anova,
I'll just share.
discuss
Excuse me.
everything at a stretch. Okay. So in
Excuse
a
me, sir.
single.
Excuse me, sir. Am I audible?
If you have doubts, please come forward.
Excuse me, sir.
So I request all to open the data set number 3 in the OME file.
Sir,
It's
please
OME
excuse
file,
me.
the data set 3. I request all to open that one. The third OME file. Yeah. The third file. That's an OME.
We are all getting only PDF files,
So
sir.
I request all
Is
the
there any
third
problem?
number 3. Okay, that number you can open this. Okay. Yeah. Yes. Yes.
All PDF files, sir. Hello.
Okay. Hope my voice is audible to all of you. I'm audible. Yes. I'm just sharing the screen now. Yeah. Sorry, in between I have some more that issues that from morning onwards I didn't close this laptop. That may be a slow it's happened. Okay. Yes. Yeah. And just like to open this data set. So the data set, you can go here. Okay. So this is a data set which I shared to you. Yeah. Yes. So I request all to open this one, the OME file of survey data sets, teaching competency based, teaching competence that you can open this.
So when we are downloading the same thing in the drive, we are getting .pdf, sir. We are not getting .omb.
I don't know what the others are getting properly. Okay. With you downloaded or you're opening, madam? You can one thing you can right click. You can right click and open with Zomo software. There is an option to open with, You can try with open with Zomo software. Is it working? Kindly check. So right click, keep the file and the above the your mouse and the right click and do check. Okay. So this is a Jamovi file. So can we go with the one-way ANOVA first? Can we go with the one-way ANOVA? What is the basic assumption to do the one-way ANOVA? Anyone tell me? Come forward. What are the basic conditions to doing a one-way ANOVA? What is the basic conditions? What is the basic condition? We discuss. How many independent variable? How many independent variable?
One.
Only one independent variable.
One
Only one
dependent, one independent, and no extraneous.
No extraneous. Okay, in this case, just I'm briefing this. Listen, we have a data set. From this, the management only the 3 category. Local, subject, these are the 2. I mean, management's 3 category. Subject also 3 category. But all other things are only 2 category. Okay. Then you can see this. We have some knowledge as a dimension. We have some dimension like personal. Here, I'm just showing this the main variable. If you go at the end, you are getting the 3 variable. For example, teaching competency, it is my dependent variable. Teaching competency is my dependent variable, and intelligence might be extraneous variable for this example. I'm just showing this. Yeah, teaching competency. The teaching competency is here independent and dependent variable. Hope you are able to see this data view. So when you go to the data view, you can see this. So you can see this enter. Yeah, the teaching competency is your dependent variable. and intelligence, INTL is a dependent, extraneous variable. So now I'm going to use only the ANOVA. After that, I'm going to the ANCOVA, right? I'm going to the ANOVA. Which ANOVA I'm going to do now? Which ANOVA? One-way ANOVA. Go to the one-way ANOVA.
One-way ANOVA.
When you go to the one-way ANOVA, we have this option. Dependent variable. What is the format? Kindly see me. What is the format?
Continuous.
Hope you
Continuous.
understood. Right. What is the independent variable?
Categorical.
Category.
Yes, this is the basic. Therefore, management, where you can keep it? Management is an
Management
independent
is
variable.
And category.
Grouping variable. Great. Then what is the dependent variable?
Teaching competency.
Competency. What is the hypothesis? Tell me the hypothesis. There is no significant effect of
Continuous.
management on teaching
teaching
competency.
competency.
Teaching competency. Is it correct? This is an hypothesis. But before that, I'm just showing this conditions, because this conditions needed when you do the one-way ANOVA. I'm just showing this because yesterday we showed some diagram, the similar kind of diagram showing for you. 1 minute. Yes. Yes, I'm opening my PowerPoint slide also. So I already uploaded the PowerPoint in our database. Okay, so you can find all these PowerPoint, because due to the time constraint, I'm not using the PowerPoint. I'm explaining everything by myself. But there is a PowerPoint which I already uploaded into your what is that? The drive link which you share now, it is there. So kindly download. You can click this my presentation. You can find all my PPTs there. Right. So I'm just opening this. This is an ANOVA. Yeah. So you know this, what is called ANOVA, ANCOVA, two-way ANOVA, three-way ANOVA, and all. So I'm just showing this, the conditions when we can use the Fisher-Tee test, when you can do the Wilks test. That's the thing. So I'm just explaining. Same like yesterday we discussed. Okay. Please, these things kindly take a screenshot, because most of the people not aware of this. When we can use this one, when you can use this Wilks and all. Okay. So hope you are getting this. Are you able to see the slides now? Yes. Now, what you can do, kindly take this. The first one, you have to do this one. What is the things you have to do this? Sorry. First, you can check the homogeneity. Oh, 1 minute. I'm just one more thing. So I'm just making, okay. This mouse I'm selecting, so you cannot know this, where I'm keeping this. Yeah. Yes. Yes, now it's somewhat, yeah, I hope you are seeing this. So in these conditions, what you can do this, you can see this. The first one, first check the homogeneity. First check the homogeneity variance. What is the test for the homogeneity? We discussed about the test name. What is the test name? Homogeneity of variance test. Levens test. It's called Levens test. Yesterday also we discussed, right? If Levens test, it is satisfying, right? If it is not significant. Non-significant means equal variance assumed. If equal variance assumed, you can go with ANOVA. ANOVA is nothing but F test, right? Suppose there is a significant array. So it's nothing but that equal variance not assumed. Then which test we can go with this? We can go with Wilks test. The same condition we discussed yesterday. And one more thing, that post hoc. So there is a post hoc that we're discussing. Suppose if it is a p value less than 0.05 after the Wilks test, you can go with this Gaines-Howell test. This is called post hoc. Suppose if it is a significant arrays in the F test, we can go with the key. So hope you are getting this. One is called Gaines-Howell. The Gaines-Howell, when you'd like to go with the Wilks test, you can go with the Gaines-Howell as a post hoc. When you go with the Fisher test, you can go with the key. Any doubts now?
So both
Any
are
doubt?
p value, both value p less than 0.05.
Yeah, P it's nothing but significant. It is significant. This also significant. If it's significant only, if it's not significant, don't go with the what is that, post hoc? Understood? No. When we can go the post hoc, if it's significant comes only in the F test, we can think about the another level of statistics. Otherwise, no need. If it's not significant, don't worry about the post hoc. Got it?
Yes, sir.
Yes, I'm just moving to my database. Okay. Okay. Now we are getting this output. Now we have the output now. Yeah, this is an output. Now kindly tell me whether we can go with the Wilks test or an EF test. Which one? Basically, it's selected Wilks. How we can check this? Which test is possible? We can check the homogeneity. Where the homogeneity option?
Homogeneity test.
Go to the assumption test. Here the homogeneity. Now you can say this. The Levens test is significant or not significant. What is it? What is the thing showing this? It is a significant. If significant means what we can do?
We need to
Equal
go for
variance not assumed. If equal variance not assumed, what is possible? What is possible?
Welch.
Welch. Got it? Now this way we can ensure. Suppose we want to get a descriptive table, click the descriptive table. Now come for the interpretation. Whether this is a p-value, this and Welch test, Welch F test. Whether significant or not significant, the p-value, the F value is 664. What is the p-value? Is less than 0.001. Is significant or not significant? Anyone? It is significant or not?
It is significant.
Significant.
It is a significant. If it's significant means what we can do? We can go with the
Welch test.
post hoc.
Yes, post hoc analysis.
Post hoc, right? What is the finding here? What is the finding? What is the finding? There is
significant difference.
And difference.
Yeah. Instead of difference, you can use the word significant effect. There is a significant effect of management on
management on teaching competency.
Hope you are getting this answer. Findings. Yes. Now,
Yes.
Now next we can go with the post hoc. What the post hoc is possible for this case? What the post hoc is possible? We discussed the diagram. If it is a Welch test, gains Howell. That is called unequal variance. We can go with unequal variance. That is called equal variance, not assumed. Okay. Now this in post hoc. Now we can see this government with aided. So kindly see this output. You can give this answer for me. What is the findings here? What is the findings once again here? The government, this is government and aided. Government aided, this is the main difference. What is the p-value? It is significant, right? Then government, private, this is also significant. And aided, private, this is also significant. Therefore, all the three pairs is significant. Therefore, what is the findings? What is the findings? How many findings we have now? How many findings we have? Three findings. Which are the findings? The first finding, government and aided have a significant difference. Then second finding, government, private have a significant difference. Third finding, aided and private have a significant difference. This is the findings, right? This is called one way
ANOVA.
One way ANOVA. Now we can see what is the mean score? What is the mean score?
217.9.
Okay, now we can see, I'm going to the ANCOVA. Can you do the ANCOVA now? Where you can go the ANCOVA? Analysis, ANOVA. Where you can go ANCOVA? ANCOVA, right? Go to the ANCOVA. Now, check with this. What is the dependent variable? Same, teaching competency, right? Keep it teaching competency there, teaching competency. What is our independent variable? What is our independent variable? Previous case, management. What is our covariate? We discussed. What is the covariate? What is the covariate?
Intelligence.
Intelligence. I'm just putting this. So the covariate, what is the covariate? It's a continuous, right? Now we can see this answer. You are getting this answer. Now, are you getting this answer now? So the management, you can see this, there's a one finding.
Significant.
What is the hypothesis? Can anyone tell me the hypothesis for this case? There is
significant. There is significant
Effect of management on
teaching competency.
Teaching competencies
by
considering the intelligence
covariate. Okay, or by treated as a intelligence covariate. So after controlling, what is that output? Kindly tell me. So what is that findings? You can see this. What is the findings here? The findings here, there is a significant happen. Okay. The management create a significant effect on teaching competency after controlling the effect of intelligence. Parallel intelligence also significantly counts. Okay. The intelligence significant is creating impact. But then we control it, even though after controlling also the management's create effect. You got it? But this case, the previous findings, what is the previous finding? You can see this. This also significant, right? One way ANOVA. but without controlling the
Intelligence
intelligence.
covariable.
But with controlling the intelligence also, there is a significant. This is the correct output actually, because a lot of third variable might be influences. We need to control it, right? Normally for controlling this kind of third variable effect, we are using the ANCOVA techniques, right? So hope you don't have any doubts about the ANCOVA. Can you go with the one way, two way ANOVA? Two way ANOVA now? Two way ANOVA? Yes, now I'm going to the ANOVA. So we can go with this directly ANOVA here, right? Previous one way ANOVA, go to the ANOVA now. When you go to the ANOVA, are you able to see this? Dependent variable, only one. What is your dependent variable? Teaching
Teaching
competency.
competency.
So what is my independent variable? Management, gender. Can I put like this? What is called? What is the exact statistics? What is the statistics name? What is
3
the
cross
statistics
2.
name?
3 cross 2.
It is 3 cross 2. Is it 3 cross 2? I think the management not having, I just put the locally. Okay, just check with this. Yeah. So anyone tell me why when you put the gender, no, it's showing the 0 as the results, right? Why it comes? Why it comes?
We are not testing the gender, we are testing the intelligence effect.
No. Listen, when I add as a gender as another variable, like the two independent variable, we can get the result 0, because the issue with this, we have a 3 factors. What is the factor? Management, government aided, self-finance, gender, male, female. So in this case, the male, sometimes the male, there is no student from the government sector. Sometimes the female student never be a private sectors. There is no particular group. There is no particular factor like male of government or male of aided college. There will be some chances that particular sample may not be available. That particular group represent is not there. That's the reason it comes 0. Therefore, go with the locally instead of a gender. Remove this gender, and go with the local. Now we are getting the output. Are you getting the output now? Did you get this output? This is a two-way ANOVA. It's a two-way ANOVA, right? Now the question is that how many high pass is going to check? How many high pass is going to check? It is going to check the. It's going to check the 3 high pass. What is the first hypothesis? First hypothesis, management, right? Management on teaching competency is significant or not?
Yes,
Significant or not?
significant.
Therefore, the first finding, there is a significant effect of management on
Teaching competency.
teaching competency. What is the second hypothesis?
There is a significant effect of local on teaching competency.
What is the findings? What is the findings?
Significant.
Therefore, there is a significant effect. What is the third hypothesis?
That is 1 cross 1. A 3 cross
This is called interaction effect. Listen, this is called main
Impact
effect.
of both.
This is also main effect. This is called interaction. How the management locally together going to affect the dependent variable of teaching competency. Is it significant or not?
Yes, it is significant.
Then what is the findings? There is a significant interaction effect of management and locally on
Teaching competency.
Hope you are getting the 3 outputs,
Yes.
right? Suppose in this case, everything is, it's come as a significant, then you can go to the post hoc. Go with the post hoc. When you go to the post hoc, go with this all locally, management locally, go with the Taki. So you may get this Taki, you will get the Takis, okay? Now, the first one is the management, the second one is the local. Are you able to get the third output? This is called interaction effect. What is the interaction effect? So, like government rural, government urban, government rural aided rural students, government rural aided urban students. These are the comparisons. You understood? This is called interaction effect. How the government rural students, how it's create effect, how the government urban students create effect, how the government aided students create effect. Hope you're getting this, the output. From this, we can write this. So now anyone tell this, what is the output for this case? Now you can see this one.
Kindly, could you show it once again, sir, please?
Sorry?
This
Ask the question
post-hoc-
loudly. I'm not able to hear this question clearly.
This post hoc comparison, sir, kindly could you please tell us once again?
Okay, go to the post hoc test. Go to the post hoc test. and all the management. So basically the management locally, management comes on the left side. Kindly put all the things together here and select the key. When you select the key, you are getting the three outputs. The first output is related to the management only, like a main effect. The second output is checking the local effect. Third output is talking about the interaction effect. In this, you are getting the wonderful insight that. So the insight here like this, you can see this. This is called government rural. The government rural, government urban comparisons. This is here the key. So what is the meaning? What is the meaning? What is the meaning?
It
It
is
is
showing high
significant.
impact.
No, the p-value. I am talking about p-value. This p-value is significant, not significant. It is not
It
significant.
is not
Significant.
significant, very
More
high
Therefore,
value.
therefore, what is the meaning? Therefore, there is no significant difference in the
between
factor of government rural students and government urban students.
urban students.
But here,
There is
significant.
significant.
What is the comparison? Government rural and aided rural students having a significant difference. Hope you are getting this. Like this, we are writing this interpretation. Madam, just you remain this one answer. So how many percent, you are talking about the high level, no? That how we can, for example, you want to know how much effect is there. Whether the effect, you are talking about the effect is there. For the main effect is there, as well as the interaction effect is there. Suppose you want to know that effect size. For this, we have the calculations called, you can see this is main findings. But the p-value, we understood that it's only a significant difference. But we want to know that the effect, whether it's the effect or not. How much percentage effect. For this, we have the effect size calculation called eta square or partial eta square. My recommendation, go to the partial eta square. It's wonderful too. Go to the partial eta square. Now we are getting this answer. Are you able to see the eta square answer here? Eta square in the ANOVA table.
Yes, sir.
Now, how we can write this? It is significant, right? It is significant. Basically, it is significant. But output, how we can write this means it's significant. But you can multiply by 100. Multiply by 100. Then what is the percentage multiply 100? It is
78.
therefore 78% of effect management on
Teaching
where?
competency.
Teaching competency. For the local, how much percentage effect?
34.
34%. Interaction effect, how many percentage?
52.
52%. For this, we are using the call effect size calculation. Hope you are getting this. This is called effect size calculation, right? So what we done it now? We done it here. We done it two-way ANOVA. How to do the three-way ANOVA? Any idea? Can you put the subject here? What it called now? Now what it called? What it called? Actually, the subject is not. I'm just going to the occupation. Sometimes the data sets may not be properly aligned. Yeah, just putting this one, occupation. We can check whether it's producing now. Yeah, I think it's made comes now. Yeah, this also. So what is the problem? Some of the pair is missing. For example, management locally or management occupation, some pair is missing. There is no specific pair. That's the reason it's showing 0. Then you cannot do this kind of ANCOVA then. Okay, ANOVA then. So only that ANOVA is possible, two-way ANOVA is possible only for management and locally only. Why? In the sense, other factors is not having a properly, what is that? The factor is not. For example, male, I'm talking about male government, there is no sample sometimes. Or in the case of subject, there will be science, no? The science student may not be in the government sometimes. We maybe collect the data like this. Sometimes there will be a problem with getting the collections. Sometimes that particular sample group is not be available. That's it showing the 0. So hope you are getting this, that two-way ANOVA, two-way ANOVA. Can you go with ANCOVA? Sir, partial eta square, it is meant for the ANOVA base. Cogans D for the t-test. Understood? Cogans D for the t-test. For the ANOVA, the effect size is called partial eta square. Hope you are getting this. Why? I'm just explaining. Here we need the ANOVA here. When you go here, the Cogans D is showing. Why? Because that post-hoc test, that output is related to the t-test. Are you able to see the t-test scores? Are you able to find the t-test score? Because the t-test, their effect size is called Cohen's d. For the ANOVA, their effect size is called partial eta square and eta square omega square. VG, are you getting this answer now? Hope you are getting this answer. Yeah, why Cohen's comes means because the key test is talking, the results comes a t-test, right? So that is the reason the t-test based effect size, it is called Cohen's. For the ANOVA based effect size is called partial eta square. Any response? Any doubts? Any doubts? Kindly respond. If you don't doubts, you can type in the chat box.
No, sir. No.
Okay, fine. Okay, so yeah. Yes, now I just move to the ANCOVA. Are you ready? Can you go to the ANCOVA?
Yes, sir, sure.
Okay, go to the ANCOVA. But I'm going to two-way ANCOVA now. So I'm just using the same dependent variable. You can keep this one. Teaching competency. Keep it the fixed factor, management, and gender. Sorry, locally. And what is our covariate? What is our covariate?
Intelligence.
Intelligence. Keep intelligence. And I'm just going with partial eta square. We can see the effect size. We done it previously two-way ANOVA. Now we are doing this ANCOVA. Now we can see this. What is the interaction effect? What is the interaction effect?
46%.
46. But see this previous case without any kind of controlling. What is the effect size?
52.
You understood the differences? The same thing only we are doing. The previous case there is no controlling, but now this case we are controlled. Now we are exactly know that what is the percentage of independent variable created, I mean interaction effects on the dependent variable after controlling this exogenous variable. So therefore, which findings may be more apt in ANCOVA? Because ANOVA we don't having any kind of control, but we have the control here. Hope you are getting this answer now. Two-way and ANCOVA.
Sir.
Okay. Yes. So now here also how many findings? How many findings? How many findings? Here also we have the findings. Management main effect significant, locally main effect significant, and intelligence controlling variable that was significant, but the interaction effect after controlling the intelligence also significant. Therefore, what is that answer? What is the answer?
Effects.
Yeah, so we are giving this response like there is a significant effect on management on teaching competency after controlling this intelligence. Similarly, locally, these are the main effect. There is only one interaction effect that is called, there is the interaction effect of management and locally on teaching competency after controlling the effect of intelligence. Okay, that's a covariate. Okay, so hope you are getting this. Can we go with MANOVA now? Can we go with MANOVA? Are you ready now? Hope you don't have any doubts about ANOVA and ANCOVA. Is it correct? You don't have doubts. Can you go with MANOVA?
Yes, sir,
right?
sure.
But there is no MANOVA option. What is the option they given? MANCOVA only. What we can do? Don't worry. When you go to the MANCOVA itself, if you keep the covariate, then it's called MANCOVA. If there is no covariate, then it is called
MANOVA.
MANOVA. It's very simple. What is the base? You can see this and just you can just check with this two path. When you go to the ANCOVA, dependent variable, how many space is there? What is the space? The dependent variable is small space. You cannot add this again. But when you go to the MANOVA, you can see this MANCOVA. See the space. See the space. The space is higher. Therefore, what is the meaning? What is the meaning? The difference between ANOVA and MANOVA?
Dependent variables are more.
Yes, correct. That's the reason this box default is a bit. Okay. Now, can I go with this teaching competency and managerial skill as my dependent variable? Right?
Yes, sir.
Go with the study habits also. Therefore, how many dependent variable? How many dependent variable?
3.
3.
3.
Can I use this management? Then what is called? What is the exact statistics? What is the statistics name? Anyone? What is the statistics name? It is called. What is the exact statistics name? What is the name of the statistics? It is a one-way or two-way or a three-way, ANOVA or MANOVA or MANCOVA.
MANOVA.
It is one way. It is one way.
MANOVA.
It is one way MANOVA. Why one way MANOVA? Only one independent variable. Dependent variable, we have 3. That's the reason. Suppose I'm keeping local, then what is called?
Two-way.
What it called? What it called?
Two-way
Two-way?
Manova.
Two-way?
Manova.
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 Suppose, Manova, sorry, two-way Manova. Suppose I'm keeping intelligence covariance, then what it called?
Mankova.
Two-way
Two-way
Mankova.
Yeah, now hope you are getting the clarity, right? So what is called two-way Manova, two-way Mankova, three-way Manova and all, right? Now I'm just going to explain first with one-way Mankova. Then after this, I'm just explaining this. I request all to go with only one management. I'm just explaining this. Here, we could not get this F value directly. Like we don't have a Fisher's F test or in the case of Wilks test. Instead of that, we have the tests called Pillai's test, Wilk, Lambda, Hosking test. This is a 4th test. But the 4th test we can consideration. But according to the most of statisticians, they suggest to go with this Wilks Lambda. This Wilk Lambda, it is good for the parametric basis. You can go with this Wilk Lambda. You can see this FLE for the Wilks Lambda and significant. What is this one? What is the interpretation then? What is the IPOS? Anyone tell me the IPOS? What is IPOS for this case?
There is
What is IPOS for?
significance
There is a significant effect of management on
teaching competency,
managerial skill and
study habits.
study habits.
Skill and study habits.
Oh, you have the 3 variable, right? You understood. Now the model is fit. So therefore the entire IPOS model is fit. So here it's talking about model fit. Now we can see this management on teaching competency. What is the F value? 278.
Significant.
Significant. That is what is the finding? First finding. The management effect on teaching competency. Then what about management on manager skill?
Significant.
What about management and study habits?
Significant.
You understood? So suppose if you want to, this is very simple. Why we are doing the Manova? If you want, instead of Manova, if you want to do the same analysis, we can do the 3 times ANOVA. You understood? We can do this ANOVA for teaching competency. We can do for ANOVA for manager skills. We want to do this ANOVA for the study habits. But we are doing attestation in a single time. You understood? That is the advantage of Manova. We are doing all the 3 variable comparison with respect to management in a single time. But the output same only. We check with this ANOVA. When you do this ANOVA also, the output may be same only. If you do the 3 times ANOVA, the same output, but we are getting only 1 time, right? I'm going to this one. What is IPOS for this case? Suppose I'm just going back this hypothesis. I'm keeping locally here. Management and locally. Yes. What is the hypothesis now? Anyone tell the hypothesis name? What is the hypothesis? What is the hypothesis? And if you want to make it a single hypothesis, very simple, I'm just giving the single hypothesis. There is no significant effect of management locally and its interaction. Hope you understood. I'm making single hypothesis for all the 3 hypotheses. What is the hypothesis? 1 minute. Ravi? Yeah.
Sir, in the previous example, we were not getting the interaction effect. Just the previous one.
Ravi, I'm in one meeting. I'm in the meeting. I will call within 10 minutes. After free, I will call you. Okay? Okay, I will call you. Within 10 minutes, I will call you. Okay. Sorry, madam. Please tell me. Or is it questions?
Sorry, sir. Sir, जो previous example आपने दिया था, the last one, we were not having this interaction effect that we are getting here.
Yeah, because only one independent variable only we kept.
Okay.
Because
in
we
the
don't
previous
get
one,
this.
that
Previous one,
yes.
it's called one-way. It's one-way Manova. No?
Okay, got it.
Okay. Now it's the interaction. Why? Because we have 2 independent variables. That's the reason interaction effect comes. So listen, for this case, if you want to make it a hypothesis, very simple hypothesis, instead of going with the 3 hypotheses, make it a single. There is no significant effect on management locally and its interactions on teaching competency, managerial skill and study habits. Okay, you understood? A single hypothesis we framed. But when you write this, you can see this. I'm just showing this outcome. In the case of management, this for the whether the model is fit or not. Model fit or not. Management model fit. Locally, yes. Model fit. Management interaction effect, model fit. Then you can see the down. You can see down. For the management, teaching competency, significant. Manager skills, significant. Study habits, significant. Locally, all 3 significant. even interaction effect, all the three significant. Therefore, how many findings there? Do you know how many findings?
9.
9 findings, right? This is called two-way,
COA.
what is called?
It is two-way MANOVA.
Manava. Yeah. Honey baby, Babu, I'm just explain once again the IPAS. Kindly hear this. The IPAS very simple. We have 3 independent variable. Instead of making a 3 or 6 IPAS or 9 IPAS, we can make a single IPAS very simply. There is no significant effect of management locally and its interaction. You can use the word because management and local, that's the main effect. Then you put and its interactions on teaching competency, managerial skills, study habits. Right? Hope you are getting this. Now I'm going to this one. I'm going to do a Mankova. Can you go with the intelligence now? Right.
Yeah, sure.
Right. Now I just put the intelligence. Can you tell the hypothesis now? What may be hypothesis? What is the hypothesis? Tell the single hypothesis, not
There,
any 5 or 6 hypothesis. What may be
there
single
is no significant effect of management local and its interaction
Great.
over the teaching competency, managerial skills, and study habits when covariant is intelligent is
By controlling the
controlling
covariate
the
of
covariate.
intelligence. Okay, correct. You are perfect now. You are correct. Exactly, you are correct. Now you can see this. I'm just going to this mode. Okay. I'm just showing this. The first one, the output. Kindly explain this. What about model fit?
Significant.
Fit. Locally, significant.
Significant.
Interaction effect?
All are significant, sir.
Okay, then thumbs down. Everything significant. Here also significant. Interaction effect is significant. Therefore, what is the findings? Very simple. There is a significant effect of
management
locally and its
interaction effect.
And its interaction on teaching competency, managerial skills,
and
study habits after controlling the effect of intelligence. Right. So this way we can train this. Okay. Now hope you are getting all one way ANOVA, two way ANOVA, MANOVA, Mankova. Any doubts now? So today we discussed.
Sir,
yeah.
Yes. Can we leave it up till here only? Is it necessary to go for the post hoc always, even if it is significant?
Madam, that's based on, suppose if you need to go further, if you
Okay,
need, that's up to the researcher. Okay. Because we are telling this management has a significant effect, but you want to know the management has 3 groups. No. Which groups have the, suppose government aided only have the significant difference. There is no chance for the government aided, the government self-finance. This we need to check through the postdoc only. Hope understood. So that is the reason the people are doing it. It's up to the researcher. If it's significant, if you want to do further, you can go. And I'm just going to end with a small things because we are discussing pally and non-parametric. Up to now, we're discussing about what statistics. What statistics? I'm taking 5 more minutes. Still now we're discussing only parametric. I'm just explaining the non-parametric statistics very fastly. I'm going to the ANOVA. Are you able to see the non-parametric? I received the non-parametric. What is called one-way ANOVA equivalence? What is called? One-way ANOVA, what is called?
Kruskal-Wallis.
Repeated measures ANOVA, what is called?
Friedman.
Okay. This is an advantage of the Jamovi. Even if it doesn't know what is the equivalent, suppose your data set is not such a parameter, normality, go with this Kruskal-Wallis for the one way. I'm just going to very fastly. I go to the Kruskal-Wallis, the dependent variable, teaching competency, and grouping variable management. And now we can see this one way. This output is in chi-square. Listen, most of the non-parametric, the output is come to this chi-square value only. Okay, if you want the effect size, check the effect size. Are you able to see the effect size? We already discussed. What is the effect size there?
52%.
See this answer, same answer. We done in the parametric, the same answer comes. When you do the non-parametric, you will get the same, right? Suppose we want to get this pair-wise comparison, like significant. This is called post-hoc. This is called post-hoc analysis. Hope you understood. But there is a post-hoc called Daki. What is it here? It's called Dava-Steele slow. This is also post-hoc, but this post-hoc is not here. Daki. Daki is only for the parametric. For the non-parametric, we are using the chi-square test. Is it significant or not? Is significant or not? Is significant. Is significant, right? Suppose I'm going to the manager skills. I'm just going to the manager skills also. I'm doing the multi analysis. So sorry, I'm intelligence. I'm going with the study habits. You can see the two outputs in a single. Study habits, it's also significant, only 5%, right? So this is called non-parametric. So now we finish our entire ANOVA. Even we are discussing about some of the non-parametric of the t-test, and similarly we discuss ANOVA and non-parametric. There is no doubts, hope so, right? Actually, today I maybe cover regression also, correlation regression, but today there is no time. If possible, tomorrow, I request all to join 15 minutes before, if possible. Okay. Is it okay? Because we need to cover that also. Then I'm
We'll
talking
join
about
at 6 o'clock, sir, tomorrow.
I have some program. That's the reason I told 6:50. Okay.
Okay.
So I have some programs. Okay. I request all to try for tomorrow 6:50. Otherwise, we can extend the time tomorrow night. Okay. To conclude, please kindly understand, because I need to cover what our goals, agenda. Yes. All right. Hope no doubts. Can we wind up then? If there is no doubt.
Yes, sir.
Okay. Do you know how to copy and save this the output? Because I didn't discuss. I hope you know this, right? How to do this.
We need to go to the
Right click and copy and paste. That's very simple. Okay, that you can try your end. Okay. Right. Yes. One more thing, I'm just showing this. I already shared this PowerPoint. How many of them downloaded the PowerPoint? Did you download the PowerPoint? Did you download the PowerPoint? Did you download the PowerPoint?
We have downloaded almost all the files. We need to check, sir.
But listen, every day I'm uploading new file. That is the reason I request all to check. Because if you downloaded 2 days before, you maybe lost my material, because based on my today's lecture, I maybe add some more points there. So I'm just showing this how to download. Go to this one, digital pedagogy. That link which I shared. And there you can find out. I'm just following the folder on my drive. So this is a drive only. I'm just sharing this. Okay. Yeah. So in this drive, you can see this. This is JAMA workshop resources. Go to this one. When you go to this, there is a folder number. Yeah. You can find the folder number. Statistics presented by Thiago. Click this. I added all the PowerPoint presentations like t-test, ANOVA, correlation, regression. Here you can get all the theoretical size, because due to time constraint, I'm not explaining the theory, right? Even all the theory, you can find it from here. So that PowerPoint, everything's prepared by myself only. You can share to anyone, not an issue for me. You can use it for your reference also. Okay. And suppose you want to know how to write the interpretations, I'm just giving my website. This is my website, digigogi.info. There, you want to refer my research article or my PhD, because my PhD students doing a lot of statistical based work. If you want to refer this, if you go here, this one, my research, when you go to my research part, I'm sharing this link also. So I'm just sharing this link in the chat box. So yeah, in this link, you can find out my publications, article of Scopus, as well as my PhD students. One good thing is that what is the advantages? You can download all the PhD thesis, which is awarded up to now. I have 4 completed. All the PhD awarded theses are available in South Ganga. When you click it, automatically you can find this, all the chapters. You can download all the chapters. You can refer it if you want to check. This is like an education-based dissertation, but statistics, you can refer it. That will be better. This is my Scopus article. If you want to refer it, you can refer it. Okay. And if you want to get some kind of reference idea, go to the statistics reference, this area. I'm sharing this also. I added few more points today. Yesterday, I added only few. So I just added some of the inferential statistics based some of the inference. Okay, how we can write the interpretation. I shared some of the link for you. Just to click it, it automatically directs the websites. Okay.